Estimation of a physical quantity. My dear viewers and listeners, today I am going to start the analysis of 9702 A-Level Physics exam question. The exam reference is Spring 2016. The question reference is 9702 Spring 16 question 3 paper 11. The theory of this question is from 9702 curriculum chapter 1. It is a multiple choice question on estimation of a physical quantity. According to the statement of this question, a lift is supported by two steel cables as shown in the diagram, each of length 10 meter and diameter 0.5 cm. The cables extended by 1 mm when a man of mass 80 kg steps into the lift. Look at the goal of this question. What is the best estimate of the value of the Young modulus of steel? Now come to the options. Which one is the best estimate of the value of the Young modulus of the steel? Option A, 2 times 10 raised to the power 10 Newton per meter square. Option B, 4 times 10 raised to the power 10 Newton per meter square. Option C, 2 times 10 raised to the power 11 Newton per meter square. Option D, 4 times 10 raised to the power 11 Newton per meter square. Working step 1. The Young modulus of a metal. The Young modulus of metals varies widely depending on the specific metal, but most have high values. Its range is around 13 gigapascal for lead to 400 gigapascal for tungsten. The Young modulus of steel is about 200 gigapascal. The Young modulus of aluminum is about 69 gigapascal. Working step 2. Young modulus of steel. Young modulus capital E is equal to stress over strain, which is equal to F times capital L over capital A times delta capital L. You need to find stress and strain. Stress is equal to force over area is equal to F over capital A. Strain is equal to extension over original length. Strain is equal to delta capital L over capital L. Working step 3. Stress on the cable. Stress is equal to force upon area. This is equal to F over capital A. Weight of a man is equal to force applied on the two parallel steel cables. Weight of a man is equal to mass small m times gravity small g. Mass small capital M is equal to 80 kg and gravity g is equal to 10 meter per second square approx. Weight of a man is equal to mg is equal to 80 times 10 is equal to 800 Newton is equal to force applied capital F. Area capital A is equal to question mark. You need to find or calculate this area. Working step 4. Load sharing between two parallel steel wires. When a man with a load 800 Newton steps in a lift which is supported by two steel cables, then this load is shared equally between two cables. As a result, each cable bears a load of 400 Newton. In stress calculation of single wire, 400 Newton load is used. This load produces 1 mm extension in the same wire. Same thing happens with the other wire. Working step 5. Area capital A of the cable calculation. Diameter of cable is equal to 0.5 centimeter. Area is equal to pi small d square over 4 is equal to 3.142 times bracket start 5 times 10 raised to the power minus 3 bracket close whole raised to the power 2 over 4 meter square. Area is equal to 3.142 times 25 times 10 raised to the power minus 6 whole over 4 meters square. Area is equal to 19.64 times 10 raised to the power minus 6 meters square. Working step 6. Calculation of stress of single wire. Stress is equal to force upon area is equal to capital F over capital A. Stress is equal to load applied on one wire over area of cross section of the wire. Therefore, stress is equal to 400 Newton over 19.64 times 10 raised to the power minus 6 meters square. Working step 7. Strain on the single cable. Length of the cable is equal to capital L is equal to 10 meter. Extension delta capital L is equal to 1 millimeter is equal to 1 times 10 raised to the power minus 3 meter. Strain is equal to delta capital L over capital L. Strain is equal to 1 times 10 raised to the power minus 3 meter over 10 meter. Therefore, strain is equal to 10 raised to the power minus 4. My dear learners, please subscribe this ISRA Science Education to get new updates. Working step 8. Young modulus of steel. Capital E is equal to stress into 1 over strain. This is equal to 400 over 19.64 times 10 raised to the power minus 6 into 1 over 10 raised to the power minus 4. Capital E is equal to 4 times 10 raised to the power 8 over 19.64 into 10 raised to the power 4, and this is equal to 0.2 times 10 raised to the power 8 times 10 raised to the power 4. Capital E is equal to 0.2 times 10 raised to the power 12 is equal to 2 times 10 raised to the power 11 Pascal. This value of Young modulus is comparable with option C. Therefore, option C is correct. Working step 9. Correct option. Capital E is equal to 2 times 10 raised to the power 11 Pascal. This value matches with the given value in option C for Young modulus of steel. Therefore, option C is correct. It is verified as well. Next exam question. To look for the next exam question on estimation of a physical quantity in A-Level Physics 9702, please go to ISRA Science Education, go to the video list GCE A-Level 9702, go to the question 9702, Spring 17, question 1, paper 1-1. Thank you for subscribing and watching my video lesson. Please share this video lesson with your classmates.